Hello, everyone, and welcome to another episode of the AIQURIS podcast. I'm Dr. Andreas Hauser, CEO and founder of AIQURIS, and today we are exploring how AI is reshaping the world of manufacturing, from driving productivity to enabling responsible innovation. I'm joined by Harishankar Durairaj, CTO of SeeWise.ai,
Yes.
a technology leader pioneering vision-based intelligence for manufacturing. With over a decade of experience in computer vision and software engineering, Hari is transforming traditional factories into smart, safe, and high-performing environments through AI-powered visual solutions.
Right.
Hari, it's a pleasure to have you with us. To kick off this conversation, can you tell us a bit more about your role at SeeWise.ai and the kinds of challenges you are tackling?
Fantastic. Thanks for having me here, Andrews. So this is Harishankar. I'm a CTO of SeeWise.ai. At SeeWise.ai, we develop agentic platform to help manufacturers increase their productivity, safety, and their compliances actually. So this way, we are making them more smarter and sustainable to help change the earth and the way manufacturing works.
Okay, great. Thank you. Let's start from a very broad basis, actually. So what are some of the biggest challenges in the manufacturing industry today, especially when it comes to digital transformation and AI technologies? What do you see?
Fantastic. We all know what all the problems that manufacturing industries have, right? I hope that doesn't need introduction. I'll talk about what problem we have in transforming them actually. So manufacturing does not have any kind of real-time visibility, okay? So all the machines, all the process in manufacturing were created to perform, produce things. They were never designed to generate or share data. But for AI, you need data, clear and structured data. So that is where everything starts. So you cannot change everything. You cannot rethink everything because manufacturing has been thought in a very good way to help things perform and produce things. So you have to like apply AI, like how you can induce AI in small parts, get the data, train your model and make the change. So that's the biggest challenge we have. So the digital twin simulation, many things are happening, but you don't have direct data. You have to put human in the loop, generate data, get the data model trained, and then deploy it. That's the biggest challenge I see because manufacturing was not AI ready.
Yeah, that's interesting. So really it's about data, making data available, accessible, use them, right? And maybe a bit more specific, in which area actually in the manufacturing process you see the biggest impact right now?
Obviously shop floor. That's where the production happens, right? So there are so many micro stoppages, downtimes that happens across the plant because most of the manufacturing is not continuous, happens in batch by batch manner. So even some minor micro stoppages induce the entire manufacturer is brought down the OE. So we have to address all these things, and we started off with shop floor, and right now we address both the shop floor, external premises, and warehouses actually.
Okay, very interesting. So a bit more on your specific solution, right? How far as I understand, your team focuses on turning existing CCTV infrastructure into intelligent systems.
Exactly.
So obviously leveraging data.
Yes.
How does that change the day-to-day operations in a factory setting? How does that look like?
Like I saying, you cannot transform everything and replace the equipments in the manufacturer. So what we did is we wanted to transform those passive infrastructure. These days manufacturers have their CCTV cameras, so we do not want it to be like pushing too many hardwares to them. We wanted to be agnostic with the hardware. We wanted to use the existing passive system and turn them into the intelligence hub. So what we did is we took their CCTV cameras that are pre-existing and connected those CCTV camera into our model, and we started generating the data through our model and refined and fine-tuned our model and help them with insights on where the production lacks, where the paternal quality and compliance reports, and that's how we are doing it.
So just to understand then, I mean, there is a machine, a series of CNC machines or whatever, right? Any type of machines, and you are watching them, basically, the magic eye somehow.
Yes.
And then can you just walk us through when you see something, an anomaly or something which is not correct, right? Just as a simple example that layman like me actually can understand
fantastic. So like even a factory is producing the same product will not have the same process actually. It is fine-tuned to their own way.
that.
So what we did is we tried to develop a forum monitoring platform. So we are creating an ultimate corpus of data corpus of four things. 4M: the man, machine, method, and material. The man is the operator, machine is the machine that is operating, material, the raw material that is used, and then the method, the compliance in which these three things needs to be operated. So we created a model, ultimate model, that can be applied across the industries. So what you can do is we are developing an agentic platform. That means you connect the CCTV camera, and then the agent will be asking you, okay, do you want monitor safety compliance or the productivity compliance? Yeah, I want you to monitor the man here. In another places, I want you to monitor the machine here. Suppose if the machine is not able to perform really, like you know the way the machine performs, right? Every 10 minutes it needs to produce certain parts.
Right.
Every 15 minutes it needs to have go for a every X minutes it needs to go for a maintenance break. So we define the normal process here. Whatever that happens, not whether the normal process is an anomaly for the agentic system, and it alerts you with the proof data that, hey, I am seeing some kind of anomaly here which is not usual. Do you want to take a look? That's how we started. So over the period you teach the agent and it gets better and produces, and it takes care of the entire autonomy.
So, okay, we could definitely spend much more time on that, but maybe just a few more questions on this. So first, how does the employee or the worker on the shop floor interact with that agent? I mean, is it talking to like a human, or how does that look like?
Fantastic. All this agentic stuff starts with when ChatGPT came up with their LLMs actually. So more of the AI right now is based on very prompts. Hey, what happened to the factory? So we wanted to turn this. A worker needs to concentrate on his job.
Yeah.
So he cannot just go talk to the machine, hey, what has happened? What is the production or something? So we wanted to make it autonomous, like an agentic platform. So he defines the prompts that he wants the agent to monitor it. So once he identifies it, it produces, hey, like let's say I'm the plant supervisor. I have like 10 to 50 kind of cameras across my workspaces. I define the agentic platform into my platform. Then what happens? The agent monitors and produces all kind of anomalies. He obviously, because AI is an evolving, not into like kind of 100% production ready. So there needs to be a human in the loop that tells the agent to learn it. That's when it keeps on learning and produces results for them.
And how long does it take that, let's say, the agent is kind of trained and really is optimized on an optimal operation level, also the agent itself?
Okay.
Weeks, months, or
no.
days? Or
Gone were the days, it was weeks or months actually. Yeah,
okay,
right.
everything
We are in the
changes.
era of minutes or hours.
So you talk about minutes and hours,
Minutes
and
and
then
hours
the
these
system
days.
knows already what's going
Exactly.
on, right?
Yes.
In principle.
Yes. Even when we started, we were using traditional machine learning models. But right now, when the LLM came, we started using vision language models, where the deep learning is actually put into place in the learning.
Still a bit on a broader level, right? I mean, we see these recent innovations, and one is your solution, right?
Right.
I mean, there are big players like Siemens, ABB, NVIDIA, and name them, right? So what are besides now your specific solution, what are other trends you see impacting the shop floor?
One good thing that I would quote here is the simulation environment actually. We all know how NVIDIA is disrupting the industry, right? So they have Omniverse blueprint actually. So with which they can actually mimic the factory setup inside an entire blueprint. So gone were the days when things needs to be physically structured, architectured to mimic and study the results. But right now with the digital twin and simulation, so that is one very good synergy that can save a lot of energy and resources, and identify, read through the data that can find pitfalls can be helpful.
So really this digital twin, the full simulation, simulation of the full process. Correct. Basically. I mean, I've also seen once a warehouse crashing and they fully simulated the details. Was very impressive. That begs another question about how does your system then plugs into such an overall digital twin or a simulation model? Is it a separate tool, or is it kind of integrated, or how does that then work together?
Right now we are not into simulation or a digital twin.
Yeah.
But what we can do is we have developed a OPC UA. It is called a Unified Architecture Framework.
Yes.
That can communicate with manufacturers majority of their equipments. So we have made our platform communicate with all kind of acid sensors, temperature, pressure, vacuum, and whatnot, and gather input from them. So we kind of integrated from those data, because whatever, like, if you're looking at a machine, if it is not working, you will just say it is not working. There's no difference between you and the IoT sensor that will not tell you. Okay. So that's where we come in. Actually, we are not directly into the simulation thing. Yeah.
Still on your solution, right? What do you see? What challenges do you see that manufacturers adopt your solution? Is there an integration challenge, or what prevents them from, buying it right away?
Fantastic. The first thing I would say is manufacturer. There is a gap between the skill set and the mindset gap. Actually, one thing is a skill set. That means manufacturer got used to the manufacturing way, got used to see things operating. But AI is more kind of an abstract and intimidating thing. So it's like everything happens in a black box. So they don't understand. Also, AI is not 100% accurate. It is evolving. It can give you 95% accuracy, 90% accuracy. But manufacturer got used to there is a Japanese team called Poka-yoke, no error. So they got used to that way. So when they see error, they are afraid to believe something. Okay, so that's one kind of a biggest drawback that the manufacturers are having it. It's because it's not their fault also. It's a kind of a gap between the mindset and skill set thing actually.
Right.
So they need understanding about how AI models work, that the mistakes are part of the AI learning curve, and then they need to adapt. So this is kind of a barrier for us to implement the solution.
Yeah, from a zero tolerance kind of
Exactly.
to a certain risk acceptance, right? Or risk acceptance, basically, that's the nature of these AI systems, right? So it's really this understanding. Another interesting point was actually, I heard that you were selected by this NVIDIA Ignition AI Accelerator program.
Yes.
So how did that impact your product development or your strategy?
It's been a game-changing one for us actually, in multiple ways. I would just pick two things. One is our product development acceleration. So we have it was an NVIDIA's first of its kind accelerator program, where along with Tribe, they have supported our product development. We had a chance to consult with NVIDIA senior developers and the technical teams. So they had suggested a lot of improvements and how we can use our softwares in a more accelerated way. That means, like, earlier, let's say this is a box that can power up to 20 to 30 cameras. With their support, we are now able to use it of 50 cameras. That's more cost friendly for our customers to be not depending on the hardware.
Okay.
The other thing is like how fast we can do those things actually. There was a latency. AI was not a real-time one actually, but right now it is real-time. SeeWise is a 100% real-time platform. So those are the ways they have helped us in our product development. Also, like in terms of GTM, it added more credibility for us actually as an NVIDIA backed startup. Right.
So
it made a penetration easier into many customers.
Yeah, it gives you credibility.
Yeah,
right?
Exactly.
Okay.
And we were approached by many partners. Yeah, these are the ways it is helping us.
So it's not only basically the technical leveraging technical NVIDIA infrastructure. It's also about getting the credibility to convince customers that this is all solid what you're doing, right?
Exactly.
Just on that note, actually, you mentioned that this is important. So is this? Well, how important do you see this is? So assume now you would have not been with this accelerator program, and you have to go there as a out of the blue kind of company, right? Would that mean that you may have only 5 customers and not 50, or a bit of sense of how much that really brought to you?
Before NVIDIA also, we had our customers. We have very good customers like Coca-Cola, Honda are our customers. Those were happened before NVIDIA. What NVIDIA made us is the acceleration to the customer. Like earlier, when we enter into the customer, we were asked, because people just don't trust AI, like I told you earlier, right? So they need proof of concept to be developed, and then they implement it, test it in their production environments, and then they bring it to production. So, but this thing with the logos that we already have, NVIDIA, I would say it has accelerated our development actually. So the time to close the deals, the needless for POCs, those kind of things has been improved.
Much faster, yeah. Okay, very interesting. No, also it shows how important these accelerator programs are, particularly for companies who come from a startup environment, basically, right?
Okay, yeah.
So, also on a more, maybe a bit more general terms, again, right? So, Industry 4.0, right? Big term for over, I don't know, when was it coined? 2018 or something? No, or even longer ago.
I think longer ago, yeah. It started in 2010s.
Yeah, also it's quite some time since this has been coined, this term, right? And it's basically describing the digital transformation manufacturing sector, right?
Right.
Some talk about Industry 5.0, 6.0, you can argue that point, whatever you name it. But how do you see the AI piece or the AI technology now changes this Industry 4.0 approach, right?
Yeah. So Industry 4.0, in its fourth revolution, it was purely meant for automation and then data generation actually. With how we can say Industry 5th revolution is that how we are going to infer the data and make the machines think actually, right? So you have all the data and automations that has, but Industry 5 is how the humans and the machine are going to interact in an intuitive way that can support sustainability with the interoperability between the human and like a data and the machines that is available. So Industry 5 is going to be leaning towards more of how things are going to work together actually. Like the AI system is supporting humans. It's not definitely going to replace humans, I would say. It is like make human like if human is 70% efficient, AI system is going to make 140% efficient. That's how it is going to change it. That's how Industry 5.0 is evolving.
And I mean, LLM was a game changer in the sense that we have now a nice interface to talk to machines.
Exactly.
Right? So that's definitely, okay, Industry 5.0. You mentioned already agentic AI, right? Other deep tech innovations, they're all gaining momentum right now.
Exactly.
How do you see actually the impact moving forward on these technologies? I mean, we talked already about the digital twin, the simulation. So how do you see this is evolving over the next years?
Cool. Like I was saying, the manufacturing industry so far have been reactive. So the agentic platforms are going to make them proactive actually. So it is going to monitor like with also the agentic AI is becoming very democratic. So you know it decentralized the AI approach. You know earlier the data was centralized thing. So with agentic data stays in a decentralized manner and it helps them change the process in an enhanced bit actually, you see. So the agentic platform is going to make factories autonomous and with the support of humans enhance the productivity and safety and compliance protocols. I would say like, you know, factories has losses a lot of things in safety like unsafe movement and such. So these things are going to help them more stay compliant, make them more sustainable, I would say.
Right. There are two things I would like to follow up. One is basically more autonomy to the systems,
Yes.
right? But on the other hand, it's also still a human in the loop. So
Exactly.
there was, I would say, when this whole Industry 4.0 came up, there was always a discussion about the dark factory, right? No human anymore. But I mean, ultimately, there are less people on the shop floor.
Right.
Is it that at some stage there will be the lights switched off? Do you see this maybe in the next
maybe
5,
like I
10
would
years?
say like not in the next decade it would happen because those kind of dark factories are for morely automated and continuous factories, but majority of the factories are not continuous. It's of batch processing where things needs to be autonomous, right? It cannot be many things cannot be automated. Even with the big machines you cannot do it actually. So you need to have a supporting AI system that gives you more insights on how you can cut off the micro stoppages and downtimes.
I see. I mean, and the other element to this is actually this human in the loop, right?
Exactly.
So, okay, humans in the loop to do what exactly? To make sure that things are not going wrong, or to, let's say, make decisions only on a higher level? How do you see this human in the loop for is it more for controlling the risk and the issues, or because the optimization itself probably is done by then the AI systems, right?
Yes. So implementation of AI system is going to need a lot of skill set based humans actually. There needs to be human in the loop, and there will be audit trials. There will be strict fallback mechanisms for AI, because AI will not always be right. Sometimes it might be thinking a bad is a right thing, and so you need to set a lot of governance controls for AI. So there will needs to be a stakeholder kind of responsibility, where a plant manager or supervisor for the AI to teach periodically. Say there is something called model tracing. You perform you evaluate the performance of the model. So those are the areas that needs to be continuously governed for AI. Even if AI can become automated and autonomous, there needs to be a human in the loop for this activities actually.
Okay, there's still some humans in there, right, which is good. Coming a bit more to the risk piece and quality requirements, right? I mean, what we see is more and more of these tools, agents are coming into the picture, right? You mentioned at the beginning also there is certain failure modes, right?
Yes.
You will see this. So how do you make sure that you control these systems actually, that they are not going haywire, right? Or cause certain harms?
Right. So we need to develop strict governance rules for the AI. Actually, that's why the guardrails and everything is there, right? So with the perfect governance rules and periodic audit trials, you need to define a rule, like AI needs to take a data. It should not take 100% autonomous, at least to that level when it is becoming evolving. So you need to provide traceability and also the complete visual data that it pertains, why it has taken the data. So moreover, as a start, what we can do is let the AI produce results, and shall I go with this decision? So human can approve it actually, instead of he tracking down everything. Metrics do that. So that kind of improvements can be done by the humans only.
How important is it for manufacturers? I understand they want to know the functionality, the productivity gains, efficiency gains, and all these, let's say, KPIs, right? And then we have the risk and the governance.
Right.
How much are manufacturers aware that they need this, and how much are they also willing to put effort into this, right? Or is it just something you have to consider, but they try to avoid it? Just a bit understanding how important is this governance piece in the overall projects you are doing.
I think recent days the AI awareness is catching up very faster actually. Because we have been into the space for the 5+ years into this research, developing computer vision for manufacturing. Back then, people are really hesitant, but these days, thanks to the AI era, people are catching up very quickly. So they are aware that there is a governance needed, there is a compliance needed, there is a democratic law for the AI is needed. So it is helping us actually. So we don't need to teach them from 0 to 1. So we just need to explain why. That's it.
So they're really aware that this is needed, kind
Yes,
of, right?
yes.
So
I mean, the ratio before the early days is better than the current one. Yeah.
Okay, interesting, because you compare now. What about different? Do you have, we're in Singapore right now, you do certain things in Singapore.
Yes.
You also are active in other markets?
Yes,
and
we are
countries?
majorly active in Southeast Asia, Singapore, Thailand, and Indonesia. And we have some customers in India. And we recently entered into USA as well.
Interesting. And when you now compare the readiness of these manufacturers in adopting those AI solutions, can you say something about the different maturity levels?
If I could rank them across, I would first put Southeast Asia as first. The AI awareness for manufacturing especially is huge here. I hope, I'm thankful to the ecosystem here that enables the manufacturer to capture how to use AI in some. I already see a lot of manufacturer in this domain catching up with certain things, governing AI rules, implementing small components actually. We are using vision, but there are other forms of AI as well, speech, text, and many things. People are using that actually.
Yeah.
And then I put US as second one, because they still are not AI ready yet compared to the advancements that is happening in Southeast Asia. And then it comes India, where people are starting to aware that, there is a technology that we can use.
I mean, you are in the discrete manufacturing space, I understand, right? Do you also see difference in the different industries? Also, discrete is also working in different industries. Do you see any differences there?
There is a lot of process and nuance-based differences is there actually. Like even the same kind of factories follows different processes. So that's when we wanted to create a generic platform, because we do not wanted to focus on we don't want to be settled as a niche. We wanted to create multiple vertical AIs, vertical LLMs for each different manufacturing. But the first cause is we wanted to create a base platform for the efficiency. So hence we started with this. Going forward, we might want to need to be a niche, focusing on FMCG, pharma kind of models, because more the model has a like contextual data, more context it has, more powerful it becomes.
How do you rank the concern of data confidentiality, as in a sense that no important or sensitive data is being leaked through a system, right? I mean, every manufacturer has their IP in how to manufacture, basically, and you leverage your access to this data. How much are they concerned that this data may be leaked and someone else gets access to this?
Very, very concerned.
Okay.
So that's why we designed our system to be very, very hybrid. Not everyone is very very liberal actually. People are so conservative when it comes to data.
Right.
So we made our system to be hybrid. So if the manufacturers does not want the data to be leaving out, so we prepare the data preparation takes a lot of time, because if they are very liberal, we can put in the learnings from the other factories as well. Takes very minimal data and then combine it. But if the manufacturer is very conservative, no, we do not want our data to be mixed up with anything and not exposed with the outer domains. So the training time is going to be take a lot more time actually.
Right.
So that's why we prepared it on very hybrid, because manufacturers are very legacy based systems. They are not very liberal so far.
And how do you demonstrate then that you take care of the data? You just tell them basically we keep it on premise, for instance, or how do you convince them?
Okay, we have a standard set of protocols that we follow, like what are all the data leakage policies that we maintain, especially in terms of AI, how carefully we segregate their data and store their data and process the data. We provide all kind of compliance documents for them, and then they go through it and approve it.
Okay, okay. That's a very rigorous.
Yeah, and also like we are handling one of the very sensitive data vision.
Yes.
It's not speech. Speech can be mimicked, like text can be mimicked, but vision is can be, but can be synthetic, but it is very costlier. So vision is very, very sensitive. We are in the very, very sensitive area.
You already touched base on how do you look into the changes over the next years, right? Yes, human in the loop, a lot of agentic AI or a lot of agents around, basically. So how would you, or what would be your advice to businessmen, also leaders in this manufacturing, to anticipate this change over the next 5 to 10 years, basically? What should they do now to prepare, to really get ready and be ahead of the curve?
I would say they have to prepare themselves and the team that they have it. So obviously, if they wanted to innovate, they have to start with something simple. So I would suggest them to start with something simple, because only 2 to 3% of the factory is very, very AI aware, and we are just talking with them. Manufacturers are everywhere. Manufacturing is the basement of whatever things that we're using, the tumbler, the microphones, and everything actually, right? So people are not at AI aware, but to be in the race, to be in the innovation race, to be for a sustainable future, AI needs to be adaptable. So I would suggest the manufacturer and the leaders who are looking to adapt, start with something simple. Identify a very, very simple area, start concentrating on the problem, define the ROI very clearly so that the AI helps. So start with simple and fail too fast, because the AI ecosystem is very, very good, helpful. So if you want to fail faster to learn, make it very, very faster.
And what about the skills they need? I mean, there's a lot of discussion around you need programmers. Others say you don't need programmers, right? There's different opinions here. How do you see this?
We are in the vibe coders era where you don't need to learn programming. The future is going to be more on the prompt. You know, your mother tongue could be the language that you need to do. You know, we can take English, we can take Malay, whatever that works with them.
Right.
So you don't need to be very technical. What you need to do is you need to be like very much abstractive and intuitive to work on the problem actually. The programming and technicalities would not be a burden with the AI advancements we are in.
But you ultimately need only a principal understanding of AI systems.
Exactly.
You mentioned before, right, that there is a certain, that behaves a bit differently than these deterministic software solutions we see in all automation systems, right?
Right,
So
exactly.
a bit more conceptual understanding, but not the
More
last.
not the technicalities and the nuances, contexts, no need of learning those things.
So
we are in the AI era.
Good future then, I would say, right, for
Exactly.
the manufacturers, but they have to adopt it. Ultimately, that's really about embracing it and not waiting and seeing. So it's really about starting as soon as possible,
Exactly.
right? Because competition is fierce.
You have to start first, fail first.
Perfect. Very good. Thank you for your time today, Hari. I also thank to our viewers. If you have any questions, please drop them in the comments or share this video with your colleagues. Stay tuned for more insightful discussions with AI and tech experts. This is Dr. Andreas Hauser. See you next time. Thank you very much.
Thank you. Thank you.